Welcome back. Use of slope of a line. Where can we apply or use the slope of a line? And we have clearly said that, just read with me, we can use the slope of a line to solve problems, for example, identifying whether or not lines are Roman 1 parallel, Roman 2 perpendicular. So when you have slopes of given lines, you can be able to determine whether those lines are parallel to each other or they are perpendicular to each other. Then I need to give you very short notes on parallel lines and the relationship of their slopes, and also perpendicular lines. Have somewhere to write. Notes: parallel lines have the same slope. E.g., when you have two equations, check on the slope, this one here, and y is equals to negative 2 over 3x plus 6 is one line, the equation of one line. The other one is y is equals to negative 2 over 3 x minus 14. As long as they have the same slope, then these two lines are parallel to each other. So parallel lines have the same slope. What about perpendicular lines? So perpendicular lines are lines, so we can say these are lines. These are lines. These are lines that intersect, same as meet at a 90-degree angle, at a 90 degrees angle. These are lines that meet or intersect at a 90 degrees angle. For example, if one line runs this way, the other one runs that way, they are meeting at 90 degrees. That means these two lines are perpendicular. We can call this on line 1, call this on line 2. These two lines are perpendicular to each other. Then the relationship in their gradients. Relationship in their gradients. Products of their gradients. Now this is where the point is. Products of their gradients or slopes, products of their slopes equals -1. We are saying if line 1 has the gradient or the slope of m1 multiplied by line 2 slope, which is m2, then the answer is -1. Then that indicates that the two lines are perpendicular to each other. After saying that, we go straight to an example. What is the slope of a line that is perpendicular to 5x minus 2y is equals to 1? We have two lines here, and one of the lines we are given the equation, but the other line we are not given anything about it. So for perpendicular lines, the product of their gradient or slope or slopes is going to be -1. So the best thing we do is we arrange this 5x minus 2y in the form y is equals to mx plus c, because we want to extract the value of the slope, or m. So in this case we have 5x, we can have 5x remaining on the left hand side is equals to, we take -2y, we take 2y to the other side of the equal sign, We already have 1. And now because it's a minus here, it becomes a plus. So we have 1 plus 2y. We continue arranging it until we attain this form. We will remain with 2y on this side and take 1 to the other side where there is x. We shall have 5x. 1 is a positive on the right hand side. When it gets to the left hand side, it becomes a negative, minus 1, like that, is equals to 2y. So we have 2y is equals to 5x minus 1. If we want to remain with y, of course that is our need, we shall divide by 2 across all the factors. And we shall have 2 cancel with 2. You remain with y is equals to 5 over 2x minus 1 over 2 as our equation. And from that equation, the value of m1 is 5 over 2. That is the slope for the first equation. Let us look for the slope of the second line that is perpendicular to this one. Without forgetting that, the slope for the first line m1 is 5 over 2. We are looking for the slope for the second line. And that means m1 times m2 is negative 1. m1 is 5 over 2. Multiply by m2 gives us negative 1. Let us multiply both sides by 2 over 5 because we want to rationalize, remove it and remain with m2. On both sides we multiply by 2 over 5. 5 cancels with 5 and 2 cancels with 2. We remain with m2 is equals to negative 1 times 2 over 5 is negative 2 over 5. That is the gradient or the slope for the second line or m2. See you in the next video.